Alright, thanks for trying the practice quiz. I'll show you what I got. I figured out that this angle P up here had to be 45 degrees, since all three have to add up to 180. On the other triangle, same thing, all three angles have to add up to 180, so this one had to be 35 degrees. So I figured out, well, first of all, I knew that angle L was congruent to angle A. I figured out that angle P was congruent to angle R, and angle E to angle T. Now you should have checked the ratios of the sides. Remember, I like to do the longest first to the longest, then the shortest to the shortest, mediumest to mediumest, and check to see if those are equal. Now two of these simplify pretty nicely. Technically this one would also simplify to 1/2, and so they are equal, they are proportional. And so that means that my triangles are similar. What's the scale factor? The scale factor is 1 to 2, but it said larger to smaller. So I'm going to write 2 to 1. You don't have to write it like that. You could write it as a fraction. 2 to 1. A similarity statement is where you write triangle. Now if you did, for example, P, then L, then E, make sure you use the similar symbol. Then you had to call the second one R, then A, then T. But you could have had those in different order as long as they were corresponding. Next, I want you to grab a yellow sheet and give yourself a completion score out of 10 for yesterday's homework. Also grab a red pen or pink pencil or blue crayon, and I want you to go through and check your answers. If you're unsure about any of these, I'd be happy to answer more questions tomorrow. And today's lesson is actually super short. It's only 2 slides, so I want you to listen carefully. Yesterday we learned that in order to be similar, we have to have polygons that have all their angles congruent, all of their corresponding angles congruent, and all of the sides must be proportional. Now there's actually a shortcut for that so that you don't have to go through both steps finding all those things, but it only works for triangles, and that's the topic of today's lesson. If you have 2 triangles, it turns out that all you would need to check is the angles. And we can talk about why that works. But basically, if the angles are sized correctly, then the sides will be sized proportionally. On top of that, we really technically only need to check 2 sets of angles. Set 1 here, set 2 here. Because if those 2 angles are congruent, we know the third one will be congruent. A long time ago we learned the third angles theorem, but basically if those 2 are the same, you do 180 minus, and then angle L is going to have to match angle Z. So that's good news for us. We only have to check to make sure that 2 angles are congruent, and we know that all angles are congruent and the sides are proportional. So here's just a few examples. This is all the lesson is, so pay attention. I want to see if these triangles are similar or not. So I see that angle R is congruent to angle F. That's something. That's one set of congruent angles. Now, if I did the 180 minus trick, I'd have the 71 here, the 78 there. What's that? 149. What does Q have to be in order to make that 180? 149 plus, is it 31? So if Q has to be 31, then I know that angle Q is congruent to angle G. And I've actually shown enough to be sure that those are similar. Now since they are similar, I'm going to write a similarity statement. If I start the first one PRQ, then that is going to be similar to what angle matches with P? That must be angle H. What angle matches with R? That was F. And with Q, that was G. And that's all there is to it. On this second one, it's a little tricky. You might want to just draw the triangles separately. We've got that little RTV triangle, and then we've got the big guy. What should we call that one? RQS, I suppose. And we know that angle T here is 49, and we know that angle Q is 49, but can we tell any other sets of angles that are congruent? It turns out they're sharing angle R, right? Angle R has to be congruent to angle R. Which property is that? The reflexive property. So I've got two sets of congruent angles. That means automatically V and S are congruent, those angles. On top of that, I know that all those sides are going to work out proportionally. So I can say the triangle RTV is similar to triangle RQS. Last one. Given angle L is congruent to angle, I suppose I better call that ONP. So I've got one given set of congruent angles. Do I have anything else? The only other thing I see is that we've got these parallel lines. Do parallel lines help us get congruent angles? Heck yes. Look at those parallel lines. If you think of this one as the transversal, do you see any congruent angles there? Maybe here and here. What kind of angles are those? Corresponding angles. So that means I know that angle LNM, I guess would be this first one, is congruent to angle, we could just call that angle P, I guess. How did we know that? The corresponding angles postulate. Fantastic. Therefore, I have enough information to tell that M is congruent to O, and all the sides are proportional. So triangle LMN is similar to triangle NOP. Lovely. That is the basis of your assignment today. Get started, finish it up, do an awesome job because it's a short lesson, a short assignment, and I will see you tomorrow.